Hello guys, this is Paul McWhorter with TopTechBoy.com, and we are here today with lesson number 28 on using your Raspberry Pi. What we are going to do in this lesson is we are going to show you how you can control a servo using the Raspberry Pi. Couple of things I need to tell you right off the bat. Number one, this is not going to be as easy as controlling a servo with the Arduino. I will say I'm going to show you step by step, and it's very straightforward. It's not just a simple matter like it is on the Arduino, though, of just writing to the servo and say go to a certain position. We've got to do a little bookkeeping. Okay, so what you need to know is in order to control the position of the servo, you have to send PWM signals to the Raspberry Pi GPIO pins. Good news is in lesson number 27, I showed you all that you needed to know about doing PWM on your GPIO pins. What I am suggesting now is that if you haven't done lesson 27 yet, or it's been a while since you've done lesson 27, go back and look at that lesson, and that will make this lesson 28 very easy. Where is lesson 27? Go to my most excellent website, www.toptechboy.com. Look at Raspberry Pi with Linux lessons, and then come down and you can click on lesson number 27, and that shows you how to get GPIO PWM on your Raspberry Pi. Okay, so that is just a heads up. Refresh your PWM. You could probably do this lesson without it, but this lesson will be easier if you go back and you look at that lesson. Okay, item number 2. Understand that your Raspberry Pi can only put out so much current. And if you hook a big old servo to your Raspberry Pi that wants more current than what your Raspberry Pi can produce, you can actually damage the Raspberry Pi. And so before I hooked this servo up to my Raspberry Pi, I looked at the spec sheet of the servo and verified that it does not require more current than what the Raspberry Pi can easily produce. If you are worried about that, what you can see is that I'm actually powering my servo through physical pin 2 on the Raspberry Pi. If you are worried about burning out your Raspberry Pi, take this power line off and go connect it to an external 5-volt supply. Drive the servo, power the servo from an external 5-volt supply, and you can still control it from the Raspberry Pi through this yellow wire. Okay, just power it from an external voltage source, control it from the Raspberry Pi. Make sure that you use a common ground. You have to connect all your grounds together for that to work. Okay, so don't burn out your Raspberry Pi. Don't hook this up and power it unless you're sure that you're okay. I'm sure that I'm okay, so I'm configuring my servo as follows. I connect the red wire to physical pin 2, which is 5 volts out on the Raspberry Pi. The black wire is ground. I am connecting that to pin 1, 3, 5, 7, 9. Physical pin 9 on the Raspberry Pi is a ground. Then physical pin 11 I use to control the servo. On my servo, black is ground, red is power, and yellow is control. If you do not have a black, a red, and a yellow wire coming off of your servo, look in the instructions and see what your color codes are. But whatever the color codes are, you can put power to pin 2, you can put ground to physical pin 9, and you can put control to physical pin 11. So let me just make sure. 1, 3, 5, 7, 9. Physical pin 9 is ground. Physical pin 11 is control. Okay, so you can hook yours up like this, and then you can follow along in these lessons. All right, I've got to stop, and I've got to talk a little bit about how servos actually work. Because if you are from the Arduino world, you think servos work by just saying right 0 or right 180 or right 90 or right whatever your desired angle is, and it just pops over there and does that. On the Raspberry Pi, it's not that easy, and we have to apply PWM signals, and we have to sort of understand how the servo works. And so I've got some important points here. I've got a little document I want to go over with you, and this will allow you to understand how the servos work. First of all, servos are controlled using PWM signals, which you learned about in Lesson 27. In Lesson 27, I showed you how to send and control PWM to your GPIO pins on the Raspberry Pi. Second thing is, most servos like to see a 50 Hertz control signal. So when you set up your PWM on your GPIO pins, you want to set it up for 50 Hertz. I'll show you how to do that in a minute, but just understand you can't, it's not good to just go in and try to use any old frequency. You want to set the frequency of your PWM signal to 50 Hertz. Good news is that's easy enough to do. Third, the position of the servo depends on the pulse width of the on part of the cycle. Okay, so when you have PWM, you have a pulse train coming across like this that you're repeating. Where the servo goes to depends on the pulse width of the on part of the cycle. How long you leave that on is what defines where the servo is going to point. Most servos are in the middle. This would be the middle like this. Most servos are in the middle with a 1.5 millisecond pulse width. So if I send a PWM signal and the width of the on part of that is 1.5 milliseconds, I'll be kind of up and down in the middle on the servo. Most servos are in the full right position at 2 milliseconds. And so if I turn this on with a 2 millisecond pulse, it'll spin over here like this. All right. And most servos are in the full left position. Let's see. I'm sorry, I need to just go over these again. Full left is 1 millisecond, middle is 1.5 millisecond, and full right is 2 milliseconds. Okay. Now, the thing is, when you do a PWM command in the Raspberry Pi, it doesn't ask you for pulse width. It asks you for duty cycle. So we need to go through some definitions and a little math to understand how to go from duty cycle to pulse width. The first thing that we have to understand is the period is equal to 1 over the frequency. When we set the Raspberry Pi up, when we do set up the PWM, we tell it what the frequency is. Well, what you've got to understand is the period is 1 over the frequency. So what frequency did we say we wanted to use? 50 Hertz. I'll show you how to do this in a minute, or this stuff is ringing a bell if you looked at lesson number 27. So for a 50 Hertz signal, the period of the signal is what? The period is 1 over the frequency. 1 over 50 is equal to 0.02 seconds, which would be 20 milliseconds. So what you need to understand is the full amount of time that we have to work with a 50 Hertz signal, the full period is 20 milliseconds. To be in the full left position, we would want a pulse width of 1 millisecond. 1 millisecond would be a duty cycle of 5%. Why? Because what's the full period? The full period is 20 milliseconds. What's 5% of 20, that's 0.05 times 20, that would equal 1 millisecond. So if I send the pin a command to go to a duty cycle of 5% with a 50 Hertz signal, that would equal 1 millisecond. So that would move the servo to the full left position. Okay? To be in the middle position, we would want a pulse width of 1.5 milliseconds. 1.5 milliseconds would be a duty cycle of 7.5%. Since 7.5% is 0.075 times 20 milliseconds would be 1.5 milliseconds. And remember, for most servos, 1.5 milliseconds would put the servo up and down. And finally, to be in the right position, all the way over here, we would want a pulse width of 2 milliseconds, which would be a duty cycle of 10%. Since 0.1, that's 10%, times 20 milliseconds, that's our whole period, would be 2 milliseconds. So we can see sort of 3 values on duty cycle to go from 0 to 90 to 180. Bottom line, to move the servo full left we need a duty cycle of 5%. For the center position, a duty cycle of 7.5%, and for full right, a duty cycle of 10%. This is all based on setting up a 50 Hertz signal to begin with. Intermediate values would just be linearly scaled between that. So you would just linearly scale your duty cycle from 5% to 10% to go from a position of 0 to 180. Okay. Now, we must test these to see if they are reasonable. In experimentation, we found, so we got to test these things and see if actually our particular servo really does what we think it should at 5, 7.5, and 10. And before we go in and do more math, we need to sort of tweak these values for our particular servo. So what do we need to do? Well, we need to call up our, let's see, not that. We need to call up our terminal window, which I should be able to do here. Okay. Pardon me, I should have had this pulled up already, but I will get it done here very quickly. Give me just a second to get this configured where you can see it. Okay, and I'm sorry I did not have this set up beforehand, but now we are in a terminal window and hopefully you can see this. All right, so now we're going to start operating the servo. What I like to do is we're going to do this all in Python, and we're going to write a Python program to do this. But as I'm learning, I like to run Python in the shell because then I can give commands one at a time and see if it does what I want. So we're going to learn how to do this, giving the commands one at a time in the shell, and then we'll come back and we'll write a program in a minute. But to enter the shell, how do we do it? We say Python. But we want to enter the shell as a super user, sudo python, because the normal Pi user does not have access to the GPIO pins. And so you want to go into the Python shell as super user, and that way it will take your commands to mess with the pins. So we're going to go sudo python. Okay, boom, those three little arrows means that we are now in the Python shell. So what's the first thing we need? Well, we need to get the RPI library. So we're going to say import, and we're going to say rpi dot GPIO as GPIO. So we're going to import the RPI library. Boom, it likes that. If you get an error here, you need to exit out of the Python shell, and you do that with a Control-D, and you need to go in and do a sudo apt-get update and a sudo apt.get upgrade, because the later versions of the operating system will have this preloaded. And so if you update and upgrade your system, you will have this. Okay, so we have loaded the library. What do we need to do now? We need to tell it what pin configuration, what pin numbering configuration we want to use. I like using the physical pins. The physical pins are the easiest because it just goes 1, 2, 3, 4, 5, 6, like that. And that's easy for me to remember. So I need to tell it to use the physical pin numbering convention. How do I do that? Well, I tell it GPIO.setMode, and then I'm going to go GPIO.board. When I say .board, that's saying to use the physical pin configuration. If I'd said .bcm, then it uses that goofy GPIO table. I've got that, I think, in lesson 25. But if you do board, you can just sort of remember what to do. So let's see if it likes that. Boom, it likes that. Now what do I need to do? I need to tell it that this pin 11 is an output pin. Remember, this is pin 1, 3, 5, 7, 9 is ground, and we're connecting and controlling through pin 11. And so we need to set up pin 11 as an output. So I'm going to say GPIO.setup, and then I'm going to say which pin? Pin 11, and it's a what? It's a GPIO.out, like that. Boom, pin 11 is now an output. Okay, now we've got to set up the pulse width modulation. So what am I going to do? I'm going to create an object called PWM, and I'm going to set it equal to GPIO.PWM. That's the command. And what do I have to tell it? Well, I've got to tell it the pin. That's 11. And then I have to tell it what? The frequency. Now that should be a comma. I got to tell it the frequency. What frequency do servos want to see? 50 hertz. We talked about that, so I say 50. Okay, boom. I now have pin 11 set up to be a 50 hertz PWM signal. But what I've got to do now is I have got to tell it to start the PWM. So I'm going to say PWM.start. And then what do I do in this particular case? I need to give it the duty cycle. Well, for a full left, I think we said a duty cycle of 5 should put it about full left. Now we're going to have to tweak these values and sort of see exactly what they are. But when I give this command, this should turn almost all the way to the left. Let's see if it does. Not quite. So let's play around with this a little more. Let's go. Now what I got to do is I've got to play with the duty cycle, and the way you do that is you say PWM dot change duty cycle. Okay, and let's say, you see I didn't go as far to the left as I wanted, so let's say go to a duty cycle of 2, and let's see if that gets it over there to the left. Boom, that got it over to the left. Let's say if we go to 3, it should be a little bit more to the right. Okay, it moves a little bit to the right. Now what did we say roughly full up and down would be? That was 7.5 if I remember right, roughly. Okay, and that's kind of, it's a little bit past, but it's kind of in the middle. And then all the way to the right, I believe we said would be 10. Okay, and that's kind of like almost all the way to the right. So you see those general purpose numbers of 5, a duty cycle of 5, 7.5, and 10 got us in the ballpark. But before we actually do the math, we want to kind of tweak those numbers so that we get it working just exactly right with this particular servo. So I want to see what the full left position is. And so instead of 5, I'm going to go all the way down to 1. So watch the servo. Okay, that sure went all the way over, but I might have gotten too far. So I'm going to look, does 2 move it at all? No, 2 didn't move it, so 2 is still full left. What, would 3 be full left? No, 3 moved a little bit to the right. So if I go back to 2, you can see 2 is really pretty darn close to all the way to the left. So now I need to see what is all the way to the right. Well, nominally, we said, so I'm going to write this down. Full left is 2. And that's a duty cycle of 2% is what that is. 2% duty cycle on a 50 hertz signal. So let's see what will take us all the way to the right. 10 does not quite take us there. Let's see if 11 does. Okay, 11 took us a little further. Let's see 12. Okay, 12 seems to even take us a little bit further. And so that 12 seems to be pretty good. So I have 2 and I have 12. If I go back to 11, you can see it backs off a little bit. If I go to 12, it goes a little further. Let's go back to all the way to the left. 2. Let's go all the way to the right. 12. Okay, so where would we expect halfway to be? Well, halfway between 2 and 12 would be 7, I do believe. And that is pretty darn right, straight up and down in the middle. Okay, so what I need to remember is the 2 points that take me to the 2 extremes are a duty cycle of 2 is full left and a duty cycle of 12 is full right. So let's go back and let's do a little math, because I want to just send it a command, basically of an angle that I want to go to, and then I want to go to that angle based on doing some math. But before I leave here, before I forget it, I'm going to turn the PWM off. So I'm going to say PWM.stop. Okay, that turns it off, and then I'm going to do GPIO.cleanup. Boom. Okay, that should kind of shut things down, and I've sort of left gracefully, and now I'm going to Control D to get back to my Linux command line. All right, now let's go in and let's do some math. Okay, so what we did was we found that 2% and 11%, what we found was that the 5%, 7.5%, and 10% weren't the perfect numbers for our servo. For our servo, we found that 2% was right on the low end and 12% was right for the full right position. This might be different on your servo, but if 2 was full left or if 5 was full left, just put that full left and full right. Just make note. For me, it was 2% was full left and 12% was full right. Yours will be a little different, but you can still follow along with the way I'm doing this. Okay. Well, if we want to input a degree setting and have it move to that position, what we would want to do is we would sort of need 2 points and draw a line between them. If we enter 0 degrees, we want it to be full left, which we know is a duty cycle of 2%. We just did the experiment. So the first point we want to work with is the point 0, which is the desired degree, and 2, which is the duty cycle, which would give me 0 degrees. Okay? If we enter 180 degrees, we want it to be full right, which would be a duty cycle of what? I'd said 11%, but really it was 12% for me. Yours might be a little bit different. This would be the point 180, 12, because if we put a duty cycle of 12, it was making it go all the way to 180. So I have 2 points. All right. If I want to go to 0, I apply a duty cycle of 2. If I want to go to 180, I apply a duty cycle of 12. And any value between 0 and 180, you just come up with an equation of the line and you can move it to any position you want perfectly. With 2 points, we can calculate the slope of the line. The slope of the line is y2 minus y1 over x2 minus x1. Well, that would be 12 minus 2 for me divided by 180 minus 0, and 12 minus 2 would be 10 over 180, which would be 1 over 18. Now you can do this, you do this with your own numbers that you find with your servo. Don't use my numbers, do it the way I'm doing it, but you've got to get the number here and here, this 2 and the 12 that were what moved your servo. Hopefully that makes sense. Now remember, the point slope form of the line is y minus y1 is equal to m over m times x minus x1. So we got to pick one of these points. You can pick either point 0 and 2 or 180 and 12, but it'd be easier to use 0 and 2, so we're going to pick that point. So y minus 2 is equal to the slope, which was, this became 1 over 18 for me. This became 1 over 18 for me. So y minus y1 is m onto x minus x1. Y minus y2 is equal to the slope, which was 1 over 18, times x minus 0. That's that 0 there. So y is equal to 1 over 18 times x plus 2. So we input the degree position we desire as x, and then we calculate y, which will be the duty cycle. So let's take this and let's use our real variable names. The duty cycle is going to be equal to 1 divided by 20 times the desired angle plus 2. Then you just plug in your desired angle and it'll calculate the duty cycle that will take you to that desired angle. Pretty cool, huh? Okay, let's see if we can write a Python program to do that. If we are going to write a Python program, we need to do what? Well, I need to ls and see I've got a folder called myPython. I'm going to put things there. If you don't have one, you could do a make directory myPython from your home directory. Mine is already there, so I'm not going to do that. I am going to go down into it. I like to go down into my folder because that way I don't have to keep typing in my path name. So I'm going to go to myPython, and then ls. You can see that I got different things there. I need to rm servo.py because I want to make that. I'd kind of practiced it before I got on camera. So now, what do I want to do? I want to create a program. How do I create a Python program? Well, I do nano, and then what do I want to create? The program servo.py. Come up with a bright, spanking, flashy, new, empty file. So how do I edit it? What's the first thing that we do? We've got to import the library. What was the library? RPI dot GPIO as GPIO. Okay. Capitalization matters. You have to do it exactly this way. Big R, big P, little I, dot GPIO, all caps, as GPIO, all caps. All right. What do we have to do now? We have to do GPIO dot set mode. Okay, GPIO is all caps, set mode is all lowercase. And then what do we do? GPIO. What is this command doing? It's saying what pin out diagram I want to use. I want to use the physical pin out. So I say what? BOARD. Remember that from earlier and from the earlier lessons. BCM if you want to use those GPIO configurations. But here, this is just straight the physical pins on the board, easy to remember. Okay. Now what do I do? Well, I'm just going to say I'm going to give my servo pin. I'm going to call that physical pin 11, and that way I don't have to keep typing 11 in. What do I need to do now? I need to set that as an output. So I do GPIO dot set up, and then which pin am I working with? Servo pin. And then what do I want it to be? I want it to be a GPIO dot out. So I'm setting servo pin to be an output pin. Servo pin is pin 11, and that's where I'm connected here. All right. Now is where things get a little tricky. I need to create my PWM object, so I'm going to say PWM. You could name this whatever you want, but then you've got to use that name from then on out. So PWM is going to be equal to GPIO dot PWM, and then which pin am I setting up? I'm setting up servo pin. That's where I want to do this. And then what frequency do I want? Okay. I think I'm going to come up, yeah, I'll just do it here. So I'll just say 50 hertz. Remember, servos want to see what frequency they want to see, 50 hertz. So I tell it 50 hertz there. That should make it happy. All right. Now, let's see. I'm going to do a for loop because I want to loop through this, and in the loop I want it to ask me what position do you want to go to, and I want to go to that position. Then I want to say what position you want to go to, and then I want to go to that position. What position you want to go to, I want to go to that position. So I'm going to do it in a for loop. So I'm going to say for I in range, okay, and where do I want to go? I want to go, let's say I want to go 20 times, and so I go from 0 to 20, which really will go stop at 19, and 0 to 19 is 20 choices, and so I'm going to be able to do this 20 times. All right. Now, how do you indicate a for loop in Python? You tab over. So what's the first thing I need to do? I'm going to say desired position is equal to input. Where do you want the servo? Question mark. And then what we are going to say is from 0 to 180. That's just telling them what range they can use. And then I'm going to put that, and then I close that off like that. Okay. Where do you want the servo? All right, I think that's going to work. I'm sorry that this is, let me bring this on out so that you can see it a little bit better. Okay, so you see that that's just saying, where do you want the servo question mark? And I'm prompting it that you can enter between between 9 and 180. Okay, I just wanted you to see that on one line so you didn't get confused by that $sign. All right, so that is straightforward. Now, what do I need to do? I needed to, before I did this, I needed to start, before the for loop, I need to start it. So I need to do pwm.start. And I just got to start somewhere. So I'm going to start roughly in the middle, which should be about 7. Okay. So PWM start, what you put here is your starting duty cycle. And so I'm started at a duty cycle of 7, which you put it about somewhere in the middle right when I turn the thing on. Okay, now I need to come down, and so I input from the user the desired position. Then I want to apply that position. So what do I do? PWM, and then what do? I say change duty cycle. All right, what do I want to change duty cycle to? Well, I want to change it to duty cycle, DC. All right, well, what is DC? I better calculate that. Okay, let me tab this over. Okay, so I better calculate duty cycle. So how do I calculate duty cycle? Well, I'm going to say duty cycle is equal to my slope. I need to peek over here again. My slope was 1 over 18. Okay, 1 divided by 18. Now listen to me. If you just put 1 divided by 18 or 1 divided by whatever your slope was for your servo, an integer divided by an integer is 0, and your thing's not going to work. So you have to force this to be floating point by saying 18 points. So if I say, let's say 1 point divided by 18 point, that forces those two numbers. That forces those two numbers to be floating point numbers, which means that you'll get a real slope when you divide that and not just get 0. Hopefully that makes sense. Times what? Times our desired position. Okay, and then if I go back and look at my equation, I believe it was plus 2. So I say plus 2. So I asked for the desired position. Based on the math we did, I know that the duty cycle should be 1 divided by 18 times the desired position plus 2. Your equation might be a little bit different for your servo. All right. Then I need to apply that with the PWM.change duty cycle to D, which I just calculated. And now that should put it there. All right, so as long as I'm in that loop, it's just going to ask me, where do you want to go? I'm going to go there. Where do you want to go? I'm going to go there. Where do you want to go? I'm going to go there. Now, in the program, we need to exit gracefully, which means we need to do some cleanup. So I need to do pwm.stop, like that, to turn the PWM off, and then I need to do a gpio.clean up, and that frees those pins up. And so you want to do this. You want to do this stuff so that you're kind of keeping your bookkeeping good and cleaning up after yourself. All right. So now, how do we save it? Control O, and then it says file name to write servo.py. I will accept that, so I click Enter, and then how do I exit out? Control X. Now, remember, you have to run this as sudo. You have to run the program as sudo so that you can access those pins. It won't let you as pi access them. So I'm going to say sudo. I am down in the same folder. Let's look. ls. I'm in the same folder with the program Servo Pi, so I don't have to give it a path name. So I can say sudo python, what program to run? Servo.py. And we'll see if I made some mistakes in there. Woo! Where do you want to set it? 9 to 180. Yeah, that's no good. Control X, Control C. All right, let's go back and edit that again. Nano Servo Pi. Okay, why did I put a 9 here? That's a 0. I want to go from I always try to use the mouse when you can't use the mouse here. Okay, that should have been 0. And also, I'll scoot this over so you can see it. I don't want my answer to the question to be jammed up against the 0, so I should put a space there. And that way it looks a little bit nicer when I run it. All right. And so now we should be able to bring this back over here like that. Okay, bring this back over here a little bit. And now we should Control O. Do I like that file name? Enter, and then Control X. Okay, now let's do a sudo python servo.py. Ooh. Import. I must have an error there. So let's go in and look and see what I did wrong. Oh, I probably accidentally typed something in there. Yeah, look at that. I hit a key that I shouldn't have, and I have an O there. So hopefully you guys saw that, and hopefully you don't have that problem. So I'm going to Control O, and then Enter, and then Control X. Now I'm going to sudo python servo py. All right. Now, it's giving me an error. It's giving me a warning because I killed the program. The program crashed before it got to that code that cleans things up. It should still run. It just gives me a warning. So where do I want to go? I thought I changed that. 9 to 180. I thought I changed that. Darn it. I'm sorry, guys. Let's go back and look at it. Okay. Sudo python servo py. Control X, Control C, something to me. Okay. Nano servo py. I need to edit it. Okay, I see what I did, like an idiot. I added the 0, but I didn't take the 9 out. So 0 to 180. Control O. File name to write servo.py. I like that, so I will click Enter, and then I will click Control X to get out of here. And now sudo python, and then what program do I want to run? Servo.py. Okay, where do you want to set the servo? Let's try 0. Now you guys, all eyes on the servo over here. All eyes on the servo. Look at that. All the way to 0. Let's see if we can go to 180. Boom, all the way to 180. Let's see if we can go 90 in the middle. Right there in the middle. And guys, do the math. Don't just guess and play with it. Do the math like I did. And you see when you do the math, your servo works exactly. And it works exactly right. And it's not like every other servo. It works perfectly for the servo that it is. Let's try 45 degrees. Boom, I'm at 45. Let's try 135. Boom, I'm at 135. Let's go back to 0. Okay, I am at 0. 90. Okay, 180. Okay, let's see. Let's go 175. Let's see if I can just back off just a little bit. Okay, you see how that moved just a little bit? Let's go to 0. Okay, now let's just go to 5. Okay, see how it moved just a little bit? This is perfect servo control. And to get the perfect servo control, you do the calibration like we did earlier in the lesson, and then you do the math. And then this thing will do whatever you want it to do. You can imagine now that we could write a program that would just smoothly step from 0 to 180. I know you guys get tired of me, but I just gotta do that. Okay. So let's play around with this. Let's go nano servo py, and this time I'll save it as a different name. But what I'm going to do is I'm going to say for I in range, let's go 0 to 180 degrees. Okay, so I'm not going to input it. I'm just going to tell it to go from 0 to 180 degrees, and then I'm going to come here and delete this. I'll go to the end and then delete all this. Okay. So I'm telling it I want to go from 0 to 100 degrees. I still have to calculate my DC, but my DC is going to be based on I this time because I'm not inputting something. So it's going to be I. Okay. And then PWM duty cycle. That should, I think that should do it. Okay. And then I'm going to kind of show my lack of remembering about Python, but I think I can go for I in range. I think I can go backwards. I'm going to say go 180, comma 0. I might need to put like a -1 in there, but we will see if this will work. Again, I work with so many different programming languages and I'm always switching between them. Sometimes I forget the syntax, but we are going to say DC is equal to 1 divided by 18 point times I plus 2, and then PWM dot change cycle, and then DC. Do you see what I'm trying to do? I'm trying to get it to smoothly go from 0 to 180 and then from 180 back to 0, and I'm just not sure about the second for loop, but we can give this a try. I'm not sure if you got to specify a step size on here or Python will figure that out. Okay, now I'm going to control X. No. Yes, I want to save it, but I want to save it as Servo 2 because I want to keep my first program. Okay, and then enter. Yes. Okay. Now let's just look at it just to make sure. So how do we do that? Cat servo.py, make sure that, or servo-2.py. Let's just look at it. Okay, that looks like it's the new program. So now we're going to do sudo python, and then what's the program? -2 this time. So let's see what happens. All eyes on the servo. Okay. You know what? I'm probably going too fast. We probably need to slow it down. So let's go back to nano servo2.py. Okay. So what we're going to do here is we're going to import time. Okay. And then down here, we got to give it a little time to settle out. Okay, so we're going to do let's do a time.sleep of 0.1 seconds, 0.05. Let's see if it can go that fast. And then here we need to do the same thing. We need to do a time.sleep. We need to do 0.05. We might need to rest longer than that if this doesn't work. Control O, yes, Control X. Okay, now we are going to sudo python server-2.py. All eyes on the servo. Okay, look at that. There it goes, nice and smooth all the way over. Is it going to go back or is it going to crash? Okay, it crashed because I probably have to put a -1 in there for kind of the step. And so let's come back. And again, I am revealing my lack of freshness in some of these commands. I'm just kind of going on my own here. So comma -1. Let's see if it'll take that. Control O to write out, enter, and Control X. And let's try running it again. Sudo python server. Okay. Okay, so now we're going to go nice and smooth from 0 to 180. And, oh, I misspelled something. Okay. Hopefully you guys caught that. Nano Servo 2. And look at that. PWM cycle. That should have been cycle. Control O, enter, Control X. Now we're going to run it again, sudo python servo2-py. Okay, now here we come from 0 to 180. Everybody is happy. And will it turn around and go back? Yes, success. It is going to go forward and backwards and forward and backwards. All right, but it's going to stop when it gets here. What if we want to make it just continue to loop? What we want is we want something sort of like the, you remember the old void loop? You kind of get a void loop for free in Arduino. Here we've got to set one up. And so what I could do here is I could say while And then I could just say while 1, because 1 is always equal to 1. So this is a while loop that's going to loop forever. But now I've got to increase my indent everywhere by 1. So that's got to be indented, that's got to be indented. Right, all these clauses are defined by the indents. And so everything's defined by the indent. And so if I'm adding a loop, I have to add indentation to all of these things. Okay. All right, so let's look at this. The while loop starts here and then it ends here. This is the first command after the while loop. The for loop, the first one starts here and this is the last indented, so all of these are part of that for loop, and then all of these are part of that for loop, and then these two for loops are indented from there. So you've kind of got nested indentation. So let's look at Control O to write out, enter, and now Control X. And now let's do it. Servo nano servo2.py. Will it work? It should just keep going back and forth nice and smooth. Oops. Sudo python servo2.py. That runs it. All eyes on the servo. Okay, boom. Here it's coming from 0 to 180. You see how nice that is? And now it's going to go back. Nice and easy, nice and easy. It goes back. And then it goes forwards. It's going to keep running. It's going to keep running. Isn't that great? I wish I could make it go a little faster. Now, if I make it go too fast, it's going to really mess up, but I'm a risk taker, so we're going to see if we can make it go faster. So I'm going to Control C to stop the program. Okay, now we're going to edit the program again. And let's see if we can make it go like about twice as fast. So we're going to stop a smaller 0.02, Control O, Control Enter, and then Control X. Now let's look at it. Sudo python server2. Whoa, look at that thing go. Look at it go. That is a thing, that's a beautiful thing to behold, doing exactly what we wanted. I wish it was going a little faster. Control C. You know what we're going to do? No, we're just going to edit it. Okay. I was going to input the speed, but I won't put you through that. I won't put you through that. You know, where you would input how fast you wanted it to go. But that will be for another day. Let's see if we can still make it go twice as fast. Okay. Control O, Enter, Control X. Okay, now let's go sudo python servo2. Whoa, look at that thing. It's flying. It is flying. I actually probably would not try to make it go much faster than this. You notice that I'm getting the full extent of motion, and it's operating smoothly, but I would probably not try to make it run any faster than that. Okay, guys, this has been a great lesson. You now can control a servo using Python and the Raspberry Pi. The great thing is that you've got a whole bunch of GPIO pins that you can use. You could control something that was walking around you. You could really go in and start doing things. Now, the secret to robotics is being able to do servo control, and you have got full control of your servo now using Python, thanks to TopTechBoy.com. Paul McWhorter, if you like this, give us a thumbs up. Think about sharing the video, maybe subscribe to us. We will see you guys later in lesson number 29. Talk to you later.